Good morning, students. Today in our class we are going to discuss energy. We'll see what is energy, how we define it, how we measure energy, how many types of energies are there, what are the units we use to measure those energies. These things we will discuss. Generally, when we observe captions, especially in India, this is the famous ad, right? So when you observe this caption, here you can see, so it is written, boost is the secret of winning energy. You are able to see here the energy, right? The word energy is very often used in our day-to-day life. When you see some examples here, right? One man does laborious work, or if a child works energetically, we say that he is full of energy. In physics too, anything that has ability to do work is said to possess energy. Now let us define energy. So energy definition is like this. The energy can be defined as the capacity to do work. How will define energy? The capacity to do work or the ability to do work is called energy. Examples: a stone cutter raises his hammer vertically above the stone and then hits it to break into small pieces. Right? When we observe in this example, he does some work in raising the hammer, right? If the hammer is allowed to fall on the stone, it can do work in breaking the stone. So here, in this example, he raised the hammer. So how he raised the hammer? By doing some work. He did work in raising the hammer. And now that raised hammer, when it is allowed to fall on the stone, it do work of breaking stone into pieces, right? So the important point what we need to observe, the work done in raising the hammer has been stored up, where it is stored up in that hammer itself, and because of that, hammer got ability to do work. Listen carefully. When we raise the hammer, that stone cutter, when he raised the hammer, he did some work, and whatever the work he did in raising the hammer, that is stored up in the same hammer as an energy. And now that is making to break the stone. That means now hammer got energy, and because of that energy, hammer is having the ability to do work. What work hammer is doing? Hammer is breaking the stones. How it got that ability? So the energy which I have given, or that a stone cutter has given to the hammer. So hammer, when it is resting on the stone, if you observe carefully, when hammer is resting on the stone, is it going to make any work? No, it can no longer do any work on the stone. Only raised hammer, when it is allowed to fall on it, so the stone is going to break. That means raised hammer is doing work, right? Why? Because it got energy, and because of that energy it is able to do work, right? So now amount of energy possessed by a body is equal to the amount of work it can do when its energy is released. This is a very important point. What is that? The amount of energy possessed by a body is always equal to what? It is equal to the amount of work it can do when that energy is released. Right? Now we'll see how we can measure the energy. We saw energy is the ability to do work. Right? Now we have to see how we can measure that, how much energy one body is having, how we can measure that. To measure what formulas we are using. So here energy as it is the capacity to do work. Its measuring formula is as same as that of work done, right? How much energy it gets, that much work it will do, right? If you raise the hammer for more height, so it gets more energy, and because of that it can do more work. So that is the important point. That means, so the energy and work both are measured by using same unit. The energy of the body is nothing but work done of the same body, right? So the energy possessed by the raised hammer is equal to the work done by the raised hammer in breaking the stones. So energy and work both are measured by using same unit. What is that unit? In SI system, we use joule to measure work, and energy also we are measuring by using same unit. So energy and work both are measured by using same unit, joule, in SI system. What about CGS system? In CGS system, we know that already work is measured in X, therefore so energy is also measured in X only, right? Energy is measured in X in CGS system. It is measured in joule in SI system. Now we'll see some other units. What are the other units we use in our day-to-day life to measure energy, especially electrical energy? So what is the electrical unit of energy? The electrical unit of energy is kilowatt hour. What is the electrical unit of energy? Kilowatt hour, right? Kilowatt hour is the energy we use. This is called commercial unit, right? The electric bill we get monthly, right? When you observe that electric bill which we get monthly is always in terms of kilowatt hours, right? So if you are getting electric bill, for example, in that electric bill it is written 50 units. What does it mean? It means the electrical appliances of your house had consumed 50 kilowatt hours of energy. Okay, 50 units mean it is equal to 50 kilowatt hours of energy. So 1 unit is equal to 1 kilowatt hour, right? 1 unit is how much? 1 kilowatt hour. So the kilowatt hour is the amount of energy used by 1000-watt electrical appliances when they operate for 1 hour. This is how we can define. What is kilowatt hour? For example, you assume you are having iron box. So its power is 1000 watt. If you are using that iron box, so of 1000-watt power, for 1 hour, the energy, electrical energy consumed by that iron box will be 1 kilowatt hour. Clear? The kilowatt hour is the amount of electrical energy used by 1000-watt electrical appliance when they operate for 1 hour. So this is how we can define kilowatt hour. So 1 kilowatt hour is nothing but kilo means 1000. So 1000 watt hours. 1000 watt hours is equal to 1 kilowatt hour. Right? Now we will see what is the relation between kilowatt hour and joule. Right? Sometimes they can ask in exam. So write the relation between kilowatt hour and joule. 1 kilowatt hour, I told kilo means 1000. Therefore 1 kilowatt hour is equal to 1000 watt hour. Right? And now you know 1 watt. 1 watt is 1 joule per 1 second. That means 1 joule work, if it is done in 1 second, then the power is called 1 watt. Right? We already know about power. So 1 watt is 1 joule per 1 second. Then 1 hour means automatically how many seconds? We know that 1 hour contains 3600 seconds. Therefore, when I substitute all these things in kilowatt hour, right? So we know 1 kilowatt hour is 1000 watt. In the place of watt, I am substituting 1 joule per second. In the place of hour, I am substituting 3600 second. Then we know that second will get cancelled. The only unit left is joule. That will be so 3.6 into 10 power 6 joules. That means 1 kilowatt hour is equal to so 3.6 into 10 power 6 joules. This is how we can get the relation between kilowatt hour and joule. Both are the units of energy. The commercial electrical unit is kilowatt hour, right? And whereas the ordinary unit, we can say in day-to-day life, the other units we are using for energy is joule, right? That is the SI unit of energy. Now we'll see different forms of energy, right? We know that there are so many types of energies are available, right? What are those different forms of energies? We know heat energy is there, electrical energy is there, chemical energy is there, light energy is there, magnetic energy is there, nuclear energy is there, sound energy is there, mechanical energy. Like that, different types. You can see the different forms of energy. Energy is available in different forms. It is in the form of heat, it is in the form of light, it is in the form of sound, it is in the form of nuclear energy, it is in the form of magnetic energy. So, energy is available in different forms. But anyhow, in our syllabus, we are going to focus only on mechanical energy. We are going to focus on mechanical energy. And remember that these all energies are interchangeable. That means you can convert one form to another form. Heat energy you can convert into light energy. Electrical energy you can convert into light energy. Chemical energy you can convert into light energy. Right? Electrical energy you can convert into sound energy. Electrical energy you can convert into mechanical energy. So these all are interchangeable. Means you can convert energy from one form to another form. Right? Now we'll see mechanical energy. That is our topic. What is mechanical energy? How we'll define mechanical energy? The energy possessed by a body due to its state of rest or of motion is called mechanical energy. What is mechanical energy? It is the energy possessed by the body by virtue of its position or by virtue of its motion. Right? Because of state of rest or because of motion, the energy possessed by the body, we call it as mechanical energy. So what are the examples we can give for mechanical energy? A falling stone is having mechanical energy. Water falling from a dam is having mechanical energy. So what are the types of mechanical energy we are going to discuss in our syllabus? The types of mechanical energies are number one, so that is kinetic energy, and other one is potential energy. So mechanical energy is found in these two forms. What are they? Kinetic energy and potential energy. In the next class we are going to see what is kinetic energy, what are the examples, how we measure kinetic energy, what is potential energy, how we measure it, what is the formula we use for it. These things we will discuss in detail. So I will stop today here. Thank you very much.